All right, welcome to our first distance learning online algebra video. We're starting with section 8.3. We had finished up through 8.2 just before spring break, so hopefully in our long break you still remember a little bit of the rules that we learned about exponents before then. But today we're looking at basically properties that deal with division and exponents. So quotient property of powers property tells us that to divide powers having the same base, subtract the exponents. So we have a to the m over a to the n. Both bases are an a. So to actually divide this, we keep that same base value, but then we subtract the bottom exponent from the top exponent. So a to the m minus n. The power of a quotient property. Find the power of a quotient, find the power of the numerator and the power of the denominator, and divide. So the power of a quotient, we have parentheses, and the power is outside the parentheses, so that means it applies to everything inside the parentheses. So that comes out as a to the m over b to the m. If those were actual numbers, then we could apply the exponents to those numbers and then divide out to get our final term. So we have several examples here. First off, 4 to the 5th over 4 to the 4th. So same base value, which is a 4, and we're going to subtract the exponents, 5 minus 4, top exponent minus the bottom exponent, which is going to give us 4 to the 1. And anything to the 1 power is just that number, so our answer is going to be 4 there. All right. So then, next one, negative 3 to the 4th over negative 3 to the 2nd. So both of those terms, same base value, different exponents. So keep the base value, negative 3, and the exponents 4 minus 2. So subtract the 2, or 4 minus 2, which is going to give us negative 3 to the 2nd power, which to the 2nd power is the same thing as negative 3 times negative 3, right? So we would have 2 negatives, which is going to make our answer positive, and 3 times 3 is 9. And really and truly, if you just look at the exponent, if what's inside the parentheses is a negative term, if it's an even exponent, then it's going to be a positive term when we finish. If it's an odd exponent with a negative inside the parentheses, it'll be a negative answer. All right, so 9 there. Next one, 6 to the 3rd times 6 to the 5th over 6 to the 9th. So we're going to deal with the top first. So 6 to the 3rd times 6 to the 5th, same base values. And we're going to add the exponents, because that's what we do when we multiply the same base value, over 6 to the 9th. And 3 plus 5 would give us 6 to the 8th over 6 to the 9th. So same base value, now we're dividing, so top exponent minus the bottom exponent, 8 minus 9. It's going to leave us with 6 to the negative 1. And if you remember from before spring break, anytime we have a negative exponent, that means we're going to move it to the other side of a fraction or give the reciprocal of it. All right, so that's technically 6 over 1. So the reciprocal of that would be 1 over 6. And once we flip it, then the exponent comes positive, so that'd be positive 1. But since it's a 1, we really don't need it, because 6 to the 1 power is just the same thing as 6. So we end up with 1 over 6. 2 over x to the 4th times x squared. So this is technically x squared over 1, so we can multiply straight across. So 2x squared over x to the 4th. Can't do anything with the 2, there's not another number, but we've got x to the 2nd over x to the 4th. So that can become 2 times x, subtract the exponents, 2 minus 4, which will be 2 times x to the negative 2 power. Once again, it's a negative, so that means the reciprocal, or we're going to move that to the other side of a fraction. So it's going to give us 2 over x squared, because the negative exponent moves the x to the second to the bottom. All right, 1/4 to the third power. So that 3 outside the parentheses goes to everything inside. So 1 to the third over 4 to the third, which is the same thing as 1 times 1 times 1 over 4 times 4 times 4. And 1 times 1 times 1 is just 1. 4 times 4 is 16, and 16 times 4 is 64. So 1/64th be our answer there. Negative 4 over x to the second power. So the negative this time is outside the parentheses. So this second power is not being applied to that negative. So no matter what we do, that negative is going to stay out the front. That 2 is going to be applied to everything inside the parentheses. So 4 to the second over x to the second. So the negative stays in front. 4 squared, 4 times 4 is 16. And x squared is going to stay x squared. So negative 16 over x squared. All right, so then 3 over 2 to the negative fourth. Once again, whatever inside the parentheses gets raised to the negative fourth power. So 3 to the negative 4 over 2 to the negative 4. Now, both of them have a negative exponent. So when we have a negative exponent, that means to flip it or give the reciprocal of it. So 3 to the negative fourth, that needs to move to the bottom of the fraction. 2 to the negative fourth, it's got a negative exponent, so it needs to move to the top of the fraction. So they're basically switching places. And when they do, their exponents are going to become positive now. So 2 to the fourth over 3 to the fourth. And so 2 to the fourth, 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. So 2 times 2 is 4, 4 times 2, 8, 8 times 2, 16. And 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So 16 over 81 will be our answer there. So next one, 3 times x to the third times y over 4 to the x times 12x squared y squared over y to the third. So we're going to multiply across first, and then we'll do the division. So 3, we can multiply times the 12. Those are both numbers, so we can multiply them together. 3 times 12 is 36. X to the third times x to the second. We're multiplying, same base values, so we add the exponents, 3 plus 2. Y times y to the second. So that first y is y to the first power. Since it doesn't have a power, we assume it's a 1. Y to the second, so 1 plus 2. And then on the bottom, 4x y to the third. None of those match up, so we can't multiply them together. 36. X to the 3 plus 2 would be x to the fifth. Y to the 1 plus 2 would be y to the third. And then 4x, which is technically x to the 1, y to the third. So now we can divide it. 36 over 4. 36 divided by 4 would be 9. And then for the x's, 5 minus 1. Y's, 3 minus 3. So we end up with 9 x to the fourth, y to the 0. And anytime we have a 0 power, that's the same thing as 1. So this is simply 9 x to the fourth. That y to the 0 basically disappears because it's 9x to the fourth times 1, which is just 9x to the fourth. And then lastly, everything inside here needs to be applied to the third power. So 3 to the third. Now this x already has an exponent, So we're raising it by another exponent called a power of a power. So that means that we multiply those exponents. So it's going to be 2 times 3. And then y to the third. So 3 to the third. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. X to the 2 times 3, which is 6. And y to the third. There's nothing to go with it, so it just stays the same. So there's as far as we can go with that one. 27 x to the 6th, y to the third. And that completes the notes for section 8.3.